Hi friends, in the previous session we have observed that complex numbers can be represented as points in the complex plane, that is also called Argand plane. For this purpose, we choose two mutually perpendicular coordinate axes, the horizontal x axis and the vertical y axis. Called the real axis and the imaginary axis respectively. To the complex number z is equal to x plus iy, there correspond the point P with the Cartesian coordinate xy. That is, here we have point P. OP is the position vector of the point. For instance, the number minus 2 plus I is represented by the point minus 2, 1 in the plane. That is here. Minus 2, 1. Addition of complex numbers correspond to the parallelogram law for addition of vectors. Thus, to add the complex numbers Z1 and Z2, we complete the parallelogram OABC whose sides OA and OC that corresponds to Z1 and Z2. That is, here we have A, the diagonal OB of this parallelogram correspond to Z1 plus Z2. The difference Z1 minus Z2. That is, Z1 minus Z2 correspond to the sum of the vectors for Z1 and minus Z2. Note that the number Z1 minus Z2 can be interpreted as the directed line segment from the point x2, y2 to x1, y1. Here we have Z1 minus Z2. Polar form of complex numbers. It is familiar that a point on the Cartesian plane can be represented by polar coordinates by taking the polar axis coincide with the positive x-axis of the Cartesian system. Then the polar coordinate r theta of a point P and the Cartesian coordinates xy of the same point are related by the equation x equal to r cos theta, y is equal to r sin theta. That is, here we have the point P, xy, this is our x, y, here theta, r. And here x is equal to r cos theta, y is equal to r sin theta. Then a non-zero complex number z is equal to x plus iy takes the so-called polar form. That is, z is equal to r cos theta plus I sin theta. Sometimes cos theta plus I sin theta is abbreviated as cis theta. Cis theta. The non-negative number r is called the length or absolute value or modulus of set, and it is denoted by mod set. And is obtained as follows, that is x square plus y square is equal to r square cos square theta plus r square sin square theta, which is equal to, here we have r square, since cos square plus sin square equal to 1, it is equal to r square, gives r is equal to mod set, which is equal to square root of x square plus y square. The number theta is called an argument or amplitude of set, and we denote it by arg set. If z is equal to 0, the coordinate theta is undefined. Using x is equal to r cos theta, y is equal to r sin theta, the value of theta can be determined from the equation tan theta is equal to y by x. We have tan theta is equal to y by x, where the quadrant containing the point corresponding to set must be specified. Principal value of arg set. Since sin theta and cos theta are periodic functions of theta with period 2 pi radian, arg set is multiple valued. However, there is one and only one way for theta lying between minus pi and pi, satisfying x equal to r cos theta, y is equal to r sin theta. This unique value of arg set such that minus pi less than arg set less than or equal to pi, that is called principal value of arg set or principal amplitude of set, and is denoted by arg set. Hence, arg set is equal to we can write arg set is equal to arg set plus 2n pi where n is equal to 0 plus or minus 1 plus or minus 2 etc. By means of the above definition, minus pi less than arg set less than or equal to pi, that is the range of the principal value is the open closed interval minus pi pi, open closed interval minus pi pi. Next we have an example. Find the principal amplitude of minus I. First one, principal amplitude of minus I. Note that minus I is equal to, we can write minus I is equal to 0 plus I into minus 1. This corresponds to 0 minus 1, which is a point that lies on the line of intersection of third and fourth quadrant. Here we have 0 minus 1. And hence, from the figure, it can be seen that principal amplitude of minus I is argument of z is equal to minus pi by 2. Here we have minus pi by 2. We also justify this as follows. That is, x is equal to r cos theta, which is equal to 0, y is equal to r sin theta, which is equal to minus 1. So, tan theta is equal to y by x, which is equal to minus 1 by 0. Therefore, theta, we can write theta is equal to tan inverse minus 1 by 0. Gives the value theta is equal to minus pi by 2, which gives theta is equal to minus pi by 2. As minus pi less than minus pi by 2 less than or equal to pi, the principal amplitude is argument of z is equal to minus pi by 2. That is arg z is equal to minus pi by 2. Next, find the principal amplitude of the complex number minus 1 plus I root 3. That is minus 1 plus I root 3. Note that minus 1 plus I root 3 is equal to minus 1 plus I into root 3. This we can write as minus 1 plus I into root 3. Corresponds to minus 1. This corresponds to minus 1 root 3. Which is a point that lies in the second quadrant. Here we have minus 1, here we have root 3. So, here we have minus 1 root 3. Also, x is equal to r cos theta, which is equal to minus 1. Here y is equal to r sin theta, y is equal to r sin theta, which is equal to square root of 3. So, the point lies in the second quadrant and hence tan theta. Here we have tan theta is equal to y by x, which is equal to root 3 by minus 1. That is theta is equal to, we have theta is equal to tan inverse root 3 by minus 1. Gives the value theta is equal to 2 pi by 3. Here we have theta is equal to 2 pi by 3. As minus pi less than 2 pi by 3, which is less than or equal to pi. The principal amplitude is argument of z is equal to 2 pi by 3. Argument of z is equal to 2 pi by 3. Next, we have to find the principal amplitude of the complex number 1. We have to find complex number 1. Note that 1 can be written as 1 plus I into 0. Corresponds to, this corresponds to 1 0, which is a point that lies in the polar axis. Hence, it's a point lies in the polar axis. Here we have 1 0. Hence, from the figure it can be seen that principal amplitude of 1 is argument of z is equal to, here we have argument of z is equal to 0. This can also be seen as follows, that is x is equal to, here x is equal to r cos theta is equal to 1, y is equal to r sin theta, which is equal to 0. So, the principal amplitude of 1 is tan inverse, we have tan inverse theta is equal to tan inverse 0 by 1, which is equal to 0. Next, find the modulus and principal amplitude of minus 1 minus I. That is principal amplitude of minus 1 minus I. For the point minus 1 minus I, modulus or length is, here we have modulus r is equal to square root of x square plus y square, which is equal to square root of minus 1 square plus minus 1 square, which is equal to square root of 2. That is, x is equal to r cos theta is equal to minus 1, y is equal to r sin theta is equal to minus 1. So, it lies in the third quadrant, and hence tan theta is equal to minus 1 by minus 1, which is equal to 1, gives the value theta is equal to minus 3 pi by 4. Here we have theta is equal to minus 3 pi by 4. As minus pi less than minus 3 pi by 4 less than or equal to pi, the principal amplitude is argument of z is equal to minus 3 pi by 4. Here we have argument of z is equal to minus 3 pi by 4. Next, we have to find the principal argument of root 3 minus I whole raised to 6. Next, we have root 3 minus I whole raised to 6. Here binomial expansion yields root 3 minus 1 whole raised to 6 is equal to root 3 whole raised to 6, root 3 whole raised to 6 plus 6c1 root 3 raised to 6 into minus I plus etc. Last we have plus minus I raised to 6, which on calculation we have, which is equal to minus 64 plus 0I. On simplification we get this. Note that minus 64 plus I0 corresponds to, this corresponds to minus 64 0, which is a point that lies on the line of intersection of second and third quadrant. That is, here we have minus 64. Hence, from figure it can be seen that principal amplitude of root 3 minus I whole raised to 6 is argument of z is equal to pi. That is, here we have pi. This can also be seen as follows. That is, x is equal to r cos theta, which is equal to minus 64. X is equal to r cos theta is equal to minus 64. Y is equal to r sin theta, which is equal to 0, which implies tan theta is equal to 0 by minus 64. Gives the value theta is equal to pi. That is, here we have theta is equal to pi. Thus, the principal amplitude is argument of z is equal to pi. Next, we have argument of minus 1 minus I is equal to minus 3 pi by 4, and it follows that argument of minus 1 minus I is equal to minus 3 pi by 4 plus 2n pi, where n is equal to 0, plus or minus 1, plus or minus 2, etc. Now, we have product and quotient. The polar form z is equal to r cos theta plus I sin theta is very useful for multiplication. For that, let z1 is equal to r1 cis theta 1 and Z2 is equal to R2 sec theta 2. We find that sec theta 1 into sec theta 2 is equal to cos theta 1 plus I sin theta 1 into cos theta 2 plus I sin theta 2. That is cos theta 1 plus I sin theta 1 into cos theta 2 plus I sin theta 2, which is equal to cos theta 1 cos theta 2, which we can write as cos theta 1 cos theta 2 minus sin theta 1 sin theta 2 again we have plus I into sin theta 1 cos theta 2 plus I into sin theta 1 cos theta 2 plus cos theta 2 sin theta 2. This gives cos theta 1 plus cos theta 1 plus theta 2 plus I sin, which we have cos theta 1 plus theta 2 plus I sin theta 1 plus theta 2 plus I sin theta 1 plus theta 2. So, this we can write it as sec theta 1 plus theta 2. Hence, Z1 into Z2 is actually equal to R1 R2 sec theta 1 sec theta 2, which is equal to R1 R2 sec theta 1 plus theta 2. We can write Z1 into Z2 is equal to R1 into R2 sec theta 1 plus theta 2. From the above, it follows that if Z is the product of two complex numbers, mod Z is the product of their moduli and arg Z is the sum of their arguments, that is modulo 2 pi. Similarly, if Z2 not equal to 0, the quotient Z1 by Z2 can be obtained by dividing the moduli and subtracting the arguments, that is Z1 by Z2 is equal to R1 by R2 sec theta 1 minus theta 2. That is, here we have Z1 by Z2, which is equal to R1 by R2 sec theta 1 minus theta 2. Now, we have to discuss exponential form. The equation e raised to I theta, which we can write as cos theta plus I sin theta, which defines the simple e raised to I theta for any real value of theta, is known as Euler's formula. With this, a complex number Z is equal to R cos theta plus I sin theta in polar form can be written in the exponential form Z is equal to R e raised to I theta, where that R is equal to modulus of Z. That is, we can write Z is equal to R e raised to I theta, where this R is equal to mod Z. If the exponential form of a non-zero complex number Z is Z is equal to R e raised to I theta, then Z inverse, we can write Z inverse is equal to 1 by R e raised to minus I theta. If Z is equal to R e raised to I theta, then length of the vector of Z lies on the circle centered at the origin. That is, here we have Z is equal to R e raised to I theta. This is our R, this is our theta. In the earlier example, we have seen that for the complex number minus 1 minus I, modulus is r is equal to square root of 2, and the principal amplitude is argument of z is equal to minus 3 pi by 4. Also r is equal to, we have square root of x square plus y square, which is equal to square root of minus 1 square plus minus 1 square, which is equal to square root of 2. Thus the point has a polar representation, that is minus 1 minus I is equal to minus 1 minus I is equal to square root of 2 into cos minus 3 pi by 4 plus I sin minus 3 pi by 4. Hence, here we have the brackets. Hence, the number minus 1 minus I has the exponential form, minus 1 minus I has the exponential form square root of 2 into exponential exponential I minus 3 pi by 4. As e raised to minus I theta is equal to e raised to I into minus theta, this can written as minus 1 minus I is equal to, minus 1 minus I is equal to square root of 2 into e raised to minus 1 into 3 pi by 4, e raised to minus 1 into 3 pi by 4. Also, there are infinite number of possibilities for the exponential form minus 1 minus I. They are given by minus 1 minus I is equal to square root of 2 into exponential I into, we can write minus 1 minus I is equal to square root of 2 into exponential I into minus 3 pi by 4, I into minus 3 pi by 4 plus 2n pi. Of course, this n is equal to 0 plus or minus 1 plus or minus 2. So, we have discussed about argument plane, principal amplitude, and we have discussed some examples also. In the next session, we will discuss about conjugate of complex numbers. So, till then, take care.